All right, we're back. We're on the bottom middle-ish of page 322, and we are going to try to determine all significant features of a given function by hand. There are a lot of significant features, so we're going to have to really cram this in. All right, so first thing that I'm looking at, I see that I can factor this, so I'm going to. Whoops. So I'm going to look at like on the function level, right? So not on a derivative, not on a second derivative, just on the function level. X minus 4, x minus 1 over x. All right, so right away, I see that there are zeros of the function. So I'm going to say zeros at x equals 4, x equals 1. All right, great. I believe there's a vertical asymptote at x equals 0. So I'm going to say VA at x equals 0. And why is there a vertical asymptote at x equals 0? Well, I need the limit as x approaches 0 from one side or the other to be infinity or negative infinity. So I'm going to say because the limit as x approaches 0 from, let's go from the right. Okay, so from the right, if I plug in, like, let's do a little sign chart here for f. So f, it's going to be 0, 1, 4. All right. So if I plug in 0.5, let's say, 0.5 gives me a negative for x minus 4, a negative for x minus 1, and then a positive, negative, negative, positive, so positive overall. So since I already know that x equals 0 is a vertical asymptote, I'm just trying to justify it. So I'm going to say the limit as x approaches 0 from the right of f of x is infinity. All right, that's justified. Now, what about because the degree of the numerator exceeds the degree of the denominator by exactly 1, I know that this function has a slant asymptote. To find the slant asymptote, what I want to do is long division, but this function is actually kind of convenient because the way it's originally written, or actually like what it is, you can do long division just by simplifying this thing. So f of x is actually equal to, so x squared divided by x is x. Negative 5x over x is just negative 5, and then plus 4 over x. Okay, so that's actually the division. So then for the slant asymptote, I want to disregard the remainder, which is 4 over x, and just take the quotient, which is x minus 5. So therefore, slant asymptote at y equals x minus 5. So far I have a lot of information, right? And I haven't taken a derivative yet. Also, I have no idea what I wrote there for asymptote. I don't know. I think I started with like AM, like asymptote or something. All right. So now I'm going to move on to derivatives and see if I can find where we're increasing, decreasing. Then the second derivative, I'll do concave up, concave down, maximums, minimums, points of inflection, whatever. I actually think this form of f of x that we found here when we reduced it for the slant asymptote is the best way to find the derivative. So maybe I'll change color because I'm on a new level, right? So f prime of x is going to be 1 because the derivative of x is 1. The derivative of negative 5 is 0. I'm thinking of 4 over x as 4x to the negative first. So its derivative is negative 4x to the negative second. So minus 4x to the negative second. I definitely, I want to rewrite that. When I find f double prime, I'm going to go back to this form because this will be the easiest place to find it. But I'm going to say right now that this is, so it's 1 minus 4 over x squared, which common denominator is x squared minus 4 over x squared, but that factors. So I'm going to make it x plus 2, x minus 2 over x squared. So where did that come from? It was 1 is x squared over x squared minus 4 over x squared. So x squared minus 4 over x squared. X squared minus 4 factors into x plus 4, x plus 2, x minus 2. So we're good there. All right, so critical points at 2 and negative 2, x equals 0 is not a critical point because it's not in the domain of the function, but it's definitely going on my sign chart. So I'm going to do a sign chart here for f prime with negative 2, with 0, and 2. All right, let's test our region. So negative a billion, negative, negative, positive, so positive overall. Comes from a first degree factor, so there's going to be a sign change. So negative. 0 comes from a second degree factor, right? X squared. So there's not going to be a sign change. If you're not sure, test something. So let's test +1, right? That'll give us a positive for x plus 2, a negative for x minus 2, and then a positive. So 1 negative, so negative overall. X equals 2 comes from a factor with a multiplicity of 1, so there's going to be a sign change, or test a billion, which is plenty easy. Pluses, so this is for f prime. Okay, so what can we say? We can say f of x is increasing for x less than -2 and x greater than 2, decreasing for -2 less than x less than 0, and 0 less than x less than 2. So why don't I just go from -2 to 2? 0 is not in the domain, so I want to like make it very clear that there's this like weird thing happening there, so I break it up. If 0 was in the domain, it's just like a weird, like a critical point that showed up like one step too early, which is kind of how I think of those, then I maybe would have gone -2 to 2. But it never hurts to break it up if you like feel like you should. So we could, I have room to justify it, so I'm going to. So I'm going to say here, because f prime greater than 0, and then here I'll say because f prime less than 0. It's not great, but like for space reasons, that's basically why I'm doing it. Space and time. All right, so increasing, decreasing. Okay, so I know relative maximum at x equals -2. Where am I putting this? I'll put it up here. F of x as relative max at x equals -2, and I can tell that because the derivative goes from positive to negative, and relative min at x equals +2. And I would love to justify that, but I just don't really have the space. But we know the justification, right? Relative maximum because the derivative goes from positive to negative, relative minimum because the derivative goes negative to positive. So for space considerations, we're not justifying it, but we really should. I think that's all we're going to get from f prime. Let's move to f double prime and see if there are any points of inflection for this thing. So for f double prime, let's go new color. F double prime. So I'm going to go back and look at this form of the derivative and say that f double prime then will be bring down the -2 to get +8 x to the -3rd. Okay, so the only 0, let's rewrite that as 8 over x cubed. So the only place is 0 or undefined is at 0, but we've already said that 0 is not in the domain, so like, so no critical points. No point of inflection. No POI because of domain of f of x. But what about concavity? All right, so let's do a sign chart for f double prime. And we'll put 0 on it. And then to the left of 0, any negative that you cube will stay negative. So negative, and then a positive cubed is positive. So f is concave down for x less than 0 because f double prime is less than 0. And f is concave up for x greater than 0 because f double prime is greater than 0. Okay, we also could use the second derivative test on our maximums and minimums because we ended up finding the second derivative and talking about it. So there's just a ton going on here. If I had infinite space, I might try to graph this. I think what I'm going to do instead is I'm going to look at the graph on a calculator and see if we got everything we're kind of like looking for. And I don't have a calculator. All right, hold on. Let's do, let's share a, all right, hold on. Whew, I got it. Don't worry, everybody. I'm on it. Here we go. Okay, calculator. So graph, I guess. Let's graph x squared minus 5x plus 4 over x. Okay, so what features did we think that we would find? We thought concave down when x is less than 0. Definitely got that. Concave up when x is greater than 0. We got that. We had a relative maximum at -2. Let's see what that is. Menu 6, option 3 for a maximum. Relative maximum there. Relative minimum at x equals 2. Menu 6, 2. And click and click. Got it. Okay. We thought that there would be zeros at 1 and 4. So I'm going to add 0 to the graph. I'm going to do menu 8, 1, 4 if you have a CX2, 8, 1, 3 if you have a CX1. Really annoying that we have to keep repeating that for the rest of our lives. Good. Got those. We thought that there would be a slant asymptote at y equals x minus 5. So x minus 5. That definitely looks right. We thought there would be a vertical asymptote at x equals 0. You can see that that is true. We thought the function would be increasing until you got to -2, decreasing -2 to 0, decreasing 0 to 2, and then increasing from 2 to infinity. We got it. I think we got everything. So I think we did a really good job, and that's the kind of thing we would do. So the only things that I would add if I were if I had infinite space, I probably would have tried to graph it, but we didn't. And also, like on the next page, we're going to talk more about how to like graph these things. So like probably jumping the gun on that. I would have preferred to have better justifications for my relative max and min, but I didn't think that I would have the space. Maybe I did in retrospect, but I don't know. But anyway, yeah, I think this is really good. I'm gonna stop this video here, and I will come back and do the next problem on this page, just because I don't want this to run on into infinity. So I will see you then, and I hope you have found this helpful. So see you then.